Welcome to the notes on simplifying radical expressions. As promised, I wanted to give you guys a list of all the perfect squares and all the perfect cubes. All right, these are really going to be important in today's lesson, so please refer to those. All right, and I'll show you exactly why that is in a second. So there you have them all. Now, first thing we're going to do is we're going to simplify a radical. All right, now it's square root 50. How are we going to simplify it? We're going to simplify using factor. All right, we're going to do a little thing called a factor tree. Now, here's the key. One of the factors has to be a perfect square, and we want to use the greatest, all right, perfect square. All right, try to use the greatest perfect square. So I look at 50. I know the factor will not be greater than 50, so I look at what's less than 50. 49 doesn't go in there, 36. No, 25 goes into square root of 50. So I'm going to say square root of 25 times the square root of 2. Again, it's not 25 times 2. It's the square root of 25 times the square root of 2 equals the square root of 50. All right, now why do I do that? Because look what happens to the square root. And I always try to list the perfect square first. The square root of 25 is 5. It's not root 5, it's 5. Okay, now we look to this other factor. Can we factor the square root of 2 with another perfect square? We can't. Well, since that we can't, this becomes our final answer, and this is all multiplication. So our final answer then is simply 5 root 2. It's that easy. Now with a cube root, how do I know it's a cube root? Because it's got that little 3 here. I look to the perfect cubes. So 24, all right? I know the factor is not going to be bigger than 24, so I only have a choice between 8 and 1, and it's not going to be 1. So it's going to be cube root of 8 times the cube root of 3, because cube root of 8 times cube root of 3 is cube root of 24. Well, look what happens. The cube root of 8, that's a perfect cube. All right, it is 2. And then the cube root of 3, that doesn't reduce. So then this is my final answer. It's just 2 cube root of 3. So if it's got the cube root, I'm looking for perfect cubes. There's the answer to this one. Now, 26. Okay, it's a perfect square. So I look at my list. What's less than 26? 16, no, that doesn't work. 9 doesn't work. 4 doesn't work. Only 1 works. So if only 1 works, which would be root 1 times square root of 26. Well, square root of 1 is 1. 1 times root 26 is just 26. So this doesn't reduce. That would be your final answer. So there may be some of those mixed into the assignment. All right, let's take a look at a couple more examples now. Now, these include the exponent, all right, or a variable, x to the third, or in this case, x to the sixth, y to the eighth. In the previous lesson on simplifying radicals, we talked about how many radicals we can bring, how many exponents we can bring out from underneath the radical. So first thing we want to do, all right, I want to change this answer right here. This is going to be a 24, all right, not 25. Okay, so first, for a problem like this, the first thing we want to do is we want to worry about the numbers first. So let's factor 24 using our perfect squares. Well, if we look back at the list, we know that the only perfect square is 4 that factors into 24. So we're going to say square root of 4 times the square root of 6. All right, so square root of 4, that becomes a 2. So I know I'm going to leave a little space here because I know I'm going to have to pull out some x's too. So I'm going to say 2. This root 6 can't break down, so that's still underneath the radical. Now, I've got an x to the third here. All right, we know there's really imaginary 2 here, so we have to divide 3 by 2. We're literally taking 3, we're dividing by 2. 2 goes into 3 one time, so I can take out 1x, x to the first. Okay, now when I take 1 times 2, I multiply 1 times 2, subtract, I have 1 remaining. Well, that means that 1x has to remain under the radical. So this would actually be my final answer. For B, now we're talking about cube roots. It's the only difference. All right, so let's break apart the 54 first. Cube root of 27 times the cube root of 2. All right, so cube root of 27, that becomes just 3. I'm going to leave some space because I don't have to worry about the x and y's. Cube root, I know that 2 is still going to be underneath there. All right, because this can't break down. Now I look to x to the 6th and y to the 8th. So I have to divide those. All right, 6 divided by 3 is 2. So I can take out x squared. All right, now the y. Divide the 8. Divide it, not the radical sign. Sorry, I'm getting a little. It's just 8 divided by 3. goes into there twice, right? 3 times 2, 6. Subtract 2. There's a remainder of 2. So that means I don't have any remainders of x because 3 times 2 is 6. So no stay in there for the x's. But the y's I'm going to have 2. So I'm going to have to say y2. So that would be my final answer in this case with the perfect cube. So if you have variables with exponents, we're going to divide them by whether it's 3 for a cube root or 2 for a square root, and you may have some that remain underneath the radical.